In the last lesson, we looked at arithmetic sequences and series. Today, we look at what's called geometric sequences and series. Let's look at this first list of numbers. Can you establish the pattern? Seems like we're multiplying by 1/2 every time, so we could extend this on forever. This is a geometric sequence because the ratio between each term is always the same. That ratio is the one term on the right divided by the term on the left. You can take any two terms and do that. So if I take these, I would take 1/16 and divide it by 1/8, and you would get 1/2. That is called their common ratio. We had the common difference in arithmetic sequence. Here we have the common ratio. You could also look at it as what are you multiplying by to get to the next term. So let's look at this one. What are we multiplying by? We are multiplying by 2. So we would have -16, -32, -64, and so forth. So my common ratio would be 2. Again, you can take any two terms and divide as long as the one on the right divided by the one on the left. Just like in arithmetic sequences, we had a recursive formula. We have that one here as well, meaning that you have to have the previous term in order to get to the next term, where R is called that common ratio. But just like in arithmetic, we also have an nth term formula that's probably going to be more helpful, which is this. So again, we have our first term, and we have the term number, and then we have R, where we have the common ratio. So let's go through some examples to just familiarize ourselves with these formulas. In this first example, we're just asked if this set creates a geometric sequence. Recall from the last lesson that N is our domain. It's the set of our counting positive numbers. So let's see if we list some out, do we get a geometric sequence? So if I let N to be 1, I would get 5 times 1 squared plus 1, so that would be 6. If N is 2, 5 times 2 squared plus 1, so I believe that's 4 times 5 is 20 plus 1 is 21. And when N is 3, I get 9 times 5 is 45, plus 1 is 46, and keep going. Have I multiplied by the same thing each time? No. Is that common ratio? Is 21 over the 6 the same as 46 over 21? No, it is not. So is this a geometric sequence? No, it is not. They do not have the same common ratio. Let's look at example number 2. Find the fifth term of a geometric sequence given this information. Now we could list them out, right? If A1 is -2 and R is 4, that means I'm multiplying by 4. So -2 times 4 is -8 times 4 times 4. And one more time, so 4 times 8 is 32. I think 512. So I know my answer is 512. Now that's not too bad because they just asked for the fifth term. But what if they asked for the 50th term? That might be cumbersome. So let's just see if we get the same answer by using our formula. Our nth term formula is A1 times R to the n minus 1 power. So I want the fifth term. A1 is -2. R is 4 to the 5 minus 1 power. So -2 times 4 to the 4th power. And no, you cannot multiply those first. Order of exponents, I need to do that exponent first. So I'd have -2 times 4 to the 4th power. I think I'll need a calculator. So 4 raised to the 4th power is 256. Multiplied times -2 is indeed -512. And yes, of course, I could have just punched this in all at one time to the calculator. So our fifth term is negative 512. Again, try to use the formulas. That's the whole purpose of these exercises, to get used to these formulas so we can apply them later. So number 2, we had the fifth term. We could write it out. The 20th term, I don't think I want to write it out. So if I look at my formula, I need the first term and I need my common ratio. So I need to find R. So R is 10 divided by 5 is 2. Of course, I'm just multiplying by 2. And my first term is 5. So I want the 20th term. So I have 5 times R to the 20th minus 1. So that's 5 times 2 to the 19th power. Going to be a fairly large number. So I have 5 times 2 raised to the 19th power. $2,621,440. So again, you could list it out like on number 2, but let's see if we can use that formula like we did on number 3. What if I want the 10th term? Ooh, we now have some square roots. Well, this is just like number 3. So we know the first term is the square root of 2, but I need to know what did I multiply by. So again, take any two terms and divide them. That's R. Could I simplify that? Yeah, let's go ahead and rationalize that denominator. Have 2 square root of 2 over 2, so that's the square root of 2. May have been easier if I would have taken the next one and said, 2 square root of 2 over 2. So again, R is the square root of 2. The first term is the square root of 2. And I want the 10th term, and that's N. So the 10th term is the first term times R raised to the 10 minus 1 power, N minus 1. And again, you cannot multiply those together. We have to do order of operations first. Now yes, you could pull up the calculator, but it's going to give you a decimal. I don't want a decimal. Let's figure out what that means. Remember, this is to the first power. That's the same base. So we have rules of exponents says you can keep the base and add those exponents. So 1 plus 9 is 10. Let's go one step further. Isn't the square root the same as the half power? Then I have rules of exponents again that say if I have a power raised to a power, I can multiply these. So 1/2 of 10 is 5. So that is 32. And yes, I guess your calculator would have given you 32, but I wanted you to see and practice those rules of exponents to simplify those square roots. Right, number 5, find the 8th term. But they gave me the second term and they gave me R. Not quite the same. So I want the 8th term. And if I have that formula, that says I need the first term. So I could go through a lot, but just think about it. So I don't have my first term. My second term is 7. If I multiply by 1/3, because remember I multiply by R, I would get 7/3. Multiply by R again, I would get 49/9, and keep going. And yes, I could figure out the 8th term. But how would I get the first term? Well, if I multiplied by 1/3 to go forward, I could divide by 1/3 to go backwards. So 7 divided by 1/3 is 21. So my first term is 21. So this is how I'm going to approach it. I'm going to say my 8th term is my first term times R to the 8 minus 1 power. That's 1/3 to the 7th power. That's 21 over 1. And then, because 1 to the 7th power is 1, but what is 3 raised to the 7th power? 2,187. So I have 21 over 2,187. So I'm going to punch that in a calculator. 21 divided by 2187. If I just said enter right now, it's going to give me a fraction. It's going to give me a decimal, but I'd like a fraction. So I'm going to go to the math button. Option 1 is fraction, and then hit enter. And my calculator is going to reduce this for me. So that's the exact answer, where if you did a decimal, you'd have to probably round. So again, use that fraction button. Very helpful. And this would be the 8th term of that sequence. Now we're going to find the 10th term. This is very much like an example we did on the arithmetic sequence where we had a system of equations. Same thing here. So our 3rd term is 1/3, and our 6th term is 1/81, and I need the 10th term. So we have this formula that we're going to apply. So we know n is 3, so a sub 3, I don't know a1, I don't know r, but n is 3. I also know the 3rd term is 1/3, so I'm going to replace that. So I have 1/3 equals the 1st term times r squared. So this information leads me to that equation. Let's do this one. So I have the 6th term is a1 times r to the 6 minus 1. But again, the 6th term is 1/81. So I have 1/81 equals the 1st term times r to the 5th power. I have those two equations. I need to solve for the 1st term and r. I can't use the elimination method by adding because of that multiplication. So I'm going to have to use the substitution method. I'm going to solve for a1. So I'm going to do that by dividing by r squared. So I have 1/3 r squared equals the 1st term. And then I'm going to substitute it into the 2nd equation. So 1/81, and in place of a1, I'm going to replace it with 1/3 r squared multiplied by r to the 5th power. Now let's just do some algebra. Reduce that, and that's going to be r cubed. So I have 1/81 equals 1/3 times r cubed. I need to get r by itself, so I'm going to multiply both sides by 3. I'm going to reduce. 3 goes into 81 27 times. And then I'm going to take the cube root of both sides, so I'm going to get r to be 1/3. Now I know r. I can come back up here and say, that's 1/3 r squared. So I have 1/3 times 1/9. So that's 1/1/3. And so a1 is 3. So I have a1, I have r, and what was the problem? It said to find the 10th term. So how do I find the 10th term? Well, the 10th term is a1 times r to the 10 minus 1 power. So that's 3 times 1/3 to the 9th power, which is 1/3 to the 8th power, just reducing. So 3 to the 8th power is 6,561. So the 10th term is 1 divided by 6,561. Go through that problem again, a little bit slower. Pause, rewind. And again, we're using a systems of equations. We're using the substitution method, solving for r, coming back, getting a, and then answering the question.